Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on Lewis structures and VSEPR, which is the molecular shapes, bond angles, and hybridizations once we figure out what the Lewis structure is. All right. General rules for drawing Lewis structures. We first need to find the total number of valence electrons that are available to us. We do this by finding the element on the periodic table and then using the group number to find the number of valence electrons. So the valence electrons are given by the last digit of the group number. So if it's in group 14, it has 4. If it's in group 18, it has 8. Once we find the total number of electrons, then we divide that number by 2, and that gives us our electron pairs. Once we have the total number of pairs available, we place the central atom in the middle, we attach all the surrounding atoms using a single bond, and then we give 3 lone pairs to each of the surrounding atoms, unless it is hydrogen. The 3 lone pairs serve to complete the octet of the surrounding atoms, and hydrogen is too small to have a total of 8 electrons, so that's why we don't put any lone pair on the hydrogen. Finally, we count how many electron pairs we've used, and then whatever is left, those go as lone pair on the central atom. All right, so let's take a look at an example. We'll start with CF4. So the first thing I want to do is count the number of valence electrons that I have available to me. Let's start with carbon. I have 1 carbon. It's in group 14, so it has 4 valence electrons, so I have a total of 4 there. Fluorine, I have 4 of them. It's group 17, so I have 7 valence electrons, so that's 28 there. 4 plus 28 is 32. 32 divided by 2 gives me 16 electron pairs to work with. Carbon is a central atom because there's only 1 of them, so then I attach each of the fluorines to the carbon. Right? And then I add 3 sets of lone pairs to complete the octet. So each bond is 2 electrons and each lone pair is 2 electrons. So I have 2, 3, 4, 5, 6, 7, 8. So 3 lone pairs gives fluorine a total of 8. So I do this for all of my fluorine. Okay, now that I have my lone pairs placed, I started with 16 electron pairs. So I'm going to count how many I've actually used. So each bond is an electron pair, and each lone pair is an electron pair. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've used 16, which means that now I have 0 left for my lone pair. All right, so I am done with my Lewis structure for carbon. So in addition to the Lewis structure, we need to find molecular shape, bond angles, and hybridization. The way in which we do that is by consulting our VSEPR chart. Okay, so to get the molecular shapes, I use the VSEPR chart. So to do that, I need to count the total number of bonding pairs, which are the number of atoms that are on the central atom. And I need to count the number of lone pairs that are around the central atom. I only care about the lone pairs that are in the middle. I don't care anything about the lone pairs that are on the surrounding atoms because those are supposed to be there. Those are there to complete the octet. So then I use the VSEPR chart to identify molecular shape, bond angle, and hybridization. All right, so if we look at our VSEPR chart, we have the bonded atoms here, and then we have the lone pair here. So I check to see which combination is true for my molecule, and that'll give me the shape, the angle or angles, and hybridization. If there are multiple angles, I put all of them because it means that my molecule has multiple types of angles there. Okay, so let's go back to our C4 example. We've drawn our shape to look like this. So if we count for bonded pairs, I have 1, 2, 3, 4 bonds. And then for lone pairs, I already established that I have 0 lone pairs on the central atom. So the carbon itself doesn't have any electrons on it other than just the bonds. All right, so I go to my VSEPR chart and I find 4 bonding pairs, 0 lone pairs. All right, so I look here, I have 4 bonding pairs, 0 lone pairs, and so that means that it is tetrahedral, bond angle is 109.5, and the hybridization is sp3. So tetrahedral shape, 109.5 for bond angle, and sp3 for hybridization. All right. Once you have your Lewis structure, we count bond pairs, we count lone pairs, and then use the VSEPR chart to figure out the rest of the information. Okay, let's do some more examples. Here we have NH3. So N, I have 1 of them, and N is in group 15, so it has 5 electrons. So I have 5. H, there are 3 of them. It's in group 1, so it has 1 valence electron, which gives me 3 total. So I have 8. 8 divided by 2 is 4 electron pairs, right? N is my central atom because I only have 1 of them. And then I connect each of my hydrogens here. All right. Now, because we have hydrogen, we can't put any lone pairs on that hydrogen because it's not big enough to hold them. So now I'm done with the bonds and the lone pairs, so now I count. So I started with 4 electron pairs, minus 1, 2, 3 from the bonds. So that's going to be 3 used, and that means that I have 1 lone pair left over. So this 1 leftover lone pair goes on the nitrogen. It goes on the central atom. Right, so I put it here. It doesn't matter where you put it. You can like squeeze them in here if you want to. Whatever floats your boat. Okay, so now I count. Bonded pairs. 1, 2, 3 bonds. Lone pairs are just 1 lone pair on the central atom. So I consult my VSEPR chart, and I see that 3 and 1, trigonal pyramidal 109.5, and sp3. So I come back up here, trigonal, pyramidal, or pyramidal, 109.5 degrees, and sp3. All right, let's do another. SEI4. So Se is selenium. It's in group 16. I have 1 of them. Each one has 6 valence electrons, so that's a total of 6. I have 4 I's in group 17, so it's 7 valence electrons for a total of 28. And so 6 plus 28 is 34. 34 divided by 2 is 17 electron pairs. All right, so now I draw my molecule. Se, I only have 1 of, so that's going to be my central atom. And then I attach all of the iodines. And then iodine is not hydrogen, so I put 3 lone pairs around each iodine to complete the octet. Bam! Magic. Now I count. I started with 17, and I have now 1, 2, 3, 4 bonds, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've used a total of 16, which means that I have 1 left for a lone pair, and then I just put that lone pair somewhere on the central atom. I can put them wherever I want to as long as I put them together. I can't do this because they're supposed to be a pair, so they need to travel as a pair. Okay, so now let's see what we have. We have for bonds, we have 1, 2, 3, 4 bonds. And for lone pair, I have 1 lone pair on the central atom. So let's find this combination on my chart. And I see that 4 and 1 is seesaw, 90 and 120, and sp3d. So I come back up here, seesaw, 90 degrees, and 120 degrees, and sp3d. Next, we have H2O, hydrogen. I have 2 of them. It's in group 1, so that's 1 electron, so that's 2 total. Oxygen, I have 1 of. It's in group 16, so it's 6 valence electrons, 6 total. And so that's 8. 8 divided by 2 is 4 electron pairs. All right, so I identify my central atom. Hydrogen is first here, but I have 2 of them. And hydrogen can never be a central atom because it can't have more than 1 bond. So oxygen, since I only have 1 oxygen, oxygen is my central atom. And then again, hydrogen cannot have more than 1 bond, so it gets 0 lone pairs. So I'm ready to count. I started with 4, 1, 2 bonds, nothing on the hydrogen, so I've used 2 electron pairs, which means that I have 2 left to make into lone pairs. So I'll just do 1 on the top and 1 on the bottom. So now we count our bonds. We have 2, and our lone pair, we also have 2. So let's come down to our sheet and find our correct combination. 2 and 2 means it's bent, 109.5 sp3. So we come back up here, bent, 109.5 degrees, and sp3 hybridized. Okay? Next one, we have XeCl4. Xe is xenon. It is in group 18, so I have 8 valence electrons. Chlorine I have 4 of in group 17, so it's 7 valence electrons, so that gives me 28. 28 plus 8 is 36. 36 divided by 2 is 18 electron pairs. I only have one xenon, so that's my central atom, so I connect all of my chlorines. And chlorine is not hydrogen, so each chlorine gets 3 lone pairs. Excellent. Now I'm ready to count. So I started with 18 electron pairs, and I have 1, 2, 3, 4 bonds, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I've used 16, and so this time I have 2 lone pairs left that go on the central atom. And I'm just going to put them across from each other because I like symmetry. All right, so now we count bonded pairs. I have 1, 2, 3, 4 bonds. And I count lone pairs. I have 1, 2 lone pairs on the central atom. So let's find this on our chart. And I see that 4 and 2 is square planar 90 sp3d2. So let's come back up here, square planar 90 degrees and sp3d2. All right, let's do one more. Here we have ArF2. Ar is argon. It is in group 18. So I have 8 fluorine, I have 2 in group 17, so I have 7, it's 14. 8 plus 14 is 22. 22 divided by 2 is 11 electron pairs. All right, so I have 11 electron pairs. So now I draw my structure. So argon is in the middle because there's only one, and then I attach each fluorine. Fluorine is not hydrogen, so each one needs 3 lone pairs. There we go. Now I count. I started with 11 electron pairs minus 1, 2 bonds, 3, 4, 5, 6, 7, 8 used. And that means I have 3 lone pairs left. So I can just fit those lone pairs however I want to on the argon. I'm just going to draw like a little house there. So I've got 3 pairs here. Okay. So let's count. Bonding pairs. I have 2 bonds. Lone pairs. I have 1, 2, 3 lone pairs. So let's look on our chart down here, and I see that 2 bonds, 3 lone pair means it's linear 180 and sp3d. So let's come back up here, linear 180 degrees and sp3d hybridization. All right, so that is how we draw Lewis structures and then use the structure to find molecular shape, bond angle, and hybridization. This has been another episode of Chemistry with Wikipedia Tutorial Edition. I hope you learned something, and until next time, keep on chemin'.